So welcome everybody to our October Tech Talk. It's our series of Tech Talks. We started a couple of years ago now as a platform for our members predominantly to come and talk about some of the exciting and innovative work they're involved with. And what we've seen is, as well as our members talking about the great stuff that we're doing, we've also got a number of projects that we're involved with or championing collaborative research and development projects to come and take the platform as well, to come and take the stage and talk about some of the interesting outcomes that we're finding in these projects. AESIN itself, just a 30-second brief, is really set up as the Technology Industry Association to support automotive electronics in the UK. And our whole thing is to keep championing the need for building strong communities and ecosystems to keep the industry alive and kicking. And there are some outstanding activities happening, and we really want to be at the forefront of championing those. With that, we have a number of interest groups, and more recently, championing some of these projects has been a key thing. Today, we have Peter Davies from Thales, who is leading the project called RESAuto. And Peter will talk more about that project. This project was it's very pioneering in terms of challenging some of the thoughts behind memory safety and the impact on the economics of vehicles. And so the project was really set out to go and explore some of that. And AESIN, very excited to be part of this. We're managing the project on behalf of Thales, as well as the dissemination partners for that as well. So I'm very excited to hear more about Peter's views and the outcomes of the project, and really delighted that he could share that also with the audience. Just to say, we are recording the session, and so if you do feel you don't want it to be yourselves to be announced, then please let us know, and we'll make sure we edit you out. We will have a Q&A at the end where we'll open the floor up for people to ask Peter questions and maybe create a bit of a discussion around the topic. With that, I'm going to pause because I know we have a strict time for the Tech Talk, and I'll hand over to Peter. Peter, please delight and surprise us with your insights on the project. Thank you.
Thank you very much, Gunny. Apologies here as I try and work out how to share my screen properly. There we go. Thank you. So this is titled under RESAuto and the Economics of Hardware Cybersecurity. And a number of you may have heard fragments of this thing in the past. But hopefully this will try and draw together some of what we've been doing in relation to this. I will try and strictly stick to 20 minutes or so to go through this presentation, which will leave time for some questions at the end. So I won't spend time on this because this is basically me. So I have been doing security of various places. So you could call me a security expert. People do that. But I think one of the things that we've been keen to actually concentrate on, we do not do security as an end in itself. We do security as a means to achieve other objectives. So what is RESAuto? So this is just a summary that's actually taken from what we were trying to, what we said we wanted to do. We wanted to demonstrate a thing called digital secure by design, which was using Cherry, which I'll talk about shortly. In the context of various things, on the context of complex interconnected systems, which are subject to international regulatory and legal controls, and with conflicting through life objectives of safety, privacy, and access to data, so competition law. And oddly, the automotive industry was an excellent basis for doing this. What we had was access to various data points, and at the end of these, I'll give you some questions, and I'll invite you, if you wish to get in touch with us, so that we could actually go through and talk about things. And uniquely, we were in a position where the automotive industry, during the 21-22 period, was actually looking at working out what it meant to have through life cyber management plans. And interestingly, it was also working out that meant it couldn't bring certain vehicles to market. So economics was clearly a big deal in relation to that. We also have access to the global insurance industry and their actuarial tables. which has allowed us to look at what the impact might be of any of these sorts of things. So whilst this is an intensely technical project, at the same time, it was basically looking at what does that mean and how do we actually change what we're doing around that. And its applications to critical national infrastructure, IoT, other things were essentially, they came out of it as things that we would be looking at. As you can see from the top there, this was led by Thales, but our partners from WMG and AESIN, we are very grateful for, and UKRI have contributed and sponsored the project that we've been operating on there. So our option was to look at what we were trying to do here was look at the economic benefits in regulated industries. Look at things like the implications for things like skills, power consumption, safety, criticality. You'll notice that security wasn't one of those. So essentially our starting position was, let's assume it does what it says, but then look at what that actually means for people that are actually trying to put it into their devices. We also considered that the automotive industry was a really good example of a complex supply chain. So we chose a way of segmenting that into three. We looked at IP suppliers, such as chip vendors. We looked at product suppliers, for example, tier ones, and we looked at system integrators. And if I had more time, I'd talk to you about the different regulatory and legal frameworks that each of these organizations have. But part of our observation was that often when you do cyber, often when you do security, it doesn't necessarily mean that those people that are bearing the costs are those that are actually reaping the benefits from doing these sorts of things. And that was part of what we were looking at. And why automotive? Well, because it's costed and monitored through life on and off vehicle in the cyber management plan. So this is almost the only industry that we're aware of where people have had to start thinking about that way, in that way. People often talk about the aircraft industry and things of that nature, but cyber was never really part of their considerations. So I believe your industry is ahead of every other industry. And as I said, the fact the unaffordability of cyber was actually a major factor in withdrawing or delaying vehicles during 2023 was a major consideration in going through this. So looking at the costs of memory security, so Cherry is to do with that mainly. So implementing safe and secure systems always entails a level of cost and things, and it's the balancing act, where you balance things like the cost of an incident against the cost of the protections, and it's a risk-based assessment that you're making in relation to that. This is well enshrined in the industry. It's the sort of thing that we had going through, and it was a fundamental part of what we were looking at in going through and looking at how did these things develop. What is Cherry? This is capability hardware enhanced risk instruction. So it's a research project which originated from Cambridge University and was aimed at improving system security through hardware support for fine-grained memory protection. And it's available over MIPS, RISC-V, ARM. We can see it in various Xilinx devices, and there is in principle, no reason it couldn't get into almost any architecture that we can think of at the moment. So it's got a good variability. We are very conscious there are other ways of achieving the same thing. And if we go for the more detailed considerations, some of those have actually come up. But the core idea was behind Cherry is to mitigate common memory vulnerabilities, so things like buffer overflows, use of free use after free errors, and by replacing things like traditional memory pointers with capabilities that enforce strict bounds and permissions. One of the really big differences between this and, for instance, using a language like Rust or Ada, if you're very old like I am, and things of this nature, was the fact that it allowed you to basically use a large part of your existing code base. So you can use your existing C and C++ programs, and we'll be able to use this in this context. And that looked like a really attractive feature that went with it. More recently, and as people have been researching this area, they've discovered that actually it's a very efficient way because of the way it handles memory errors. of being able to do efficient containerized solutions, and more or less in a way that, and at an efficiency level that was really only achievable on bare metal previously. And that's a really important factor. It potentially means you get more out of these things. And as this industry moves towards doing more containerized solution, that is definitely a plus that you might see coming out of that. So that's basically our summary of what it is and what you're actually looking at in there. And these were some of the questions we asked and we've been asking as a project. So can the Cherry solution reduce the software engineering skill set? So essentially, we're very conscious that very skilled software engineers tend to be A, very expensive, and B, in short supply. And we're an industry that over a decade has been trying to transform from primarily a mechanical one into having more software engineering capabilities and things of that nature. That was one of the real big questions that we were asking. Ultimately, we asked questions in relation to that. Can we essentially get rid of any particular skill requirement so that, for instance, you would be able to put third-party software, which might give you ways of actually allowing people to be able to achieve their right to repairs and things of that nature in a different way. Does it provide a more efficient way to diagnose memory errors prior to going to market? And that's the really important thing there. So essentially, what could we get out of this that we couldn't get out of other static analysis tools? Can it be directly deployed? So at the moment, we have versions of this that we've been testing that are based on ARM devices, but we actually can't go out there and buy all the things that we need to do. And there are some questions there about some of the certainties. So is it ready for prime time? How will the solutions affect future products or services? And what are the social and economic benefits that are realized by the solution? So would it mean, for instance, that it would reduce the cost of cyber? Would we be able to reduce the through life costs and things that went in relation to these sorts of things? We wanted to assess some of the productivity increases through the use of the solution. So would we be able to get to a better situation? So people like Microsoft and Google always talk about the huge number of errors they get that are memory related, and the fact that they can get productivity increases by getting rid of those sorts of errors. Does this give that kind of possibility? Can it give us a level of assurance that we will get an enhanced level of system and cyber resilience? That should manifest itself in a reduction in your insurance or a reduction in your cyber onboard and offboard cyber cases. And also, what are the use cases for Cherry, and how may they benefit, and how may they benefit from it? So essentially, would it be true that an OEM would benefit from this, or would it just be true that a tier one, or is it only the people doing the devices that benefit from these sorts of things? We're also very conscious that Cherry lengthens and pads pointers and addresses. So that really seems to be creating a different type of problem there. And that was part of a category of things that we were looking at. We looked at what performance overhead Cherry generated. And the good news is it's improving it in containers. It's more or less acceptable from an energy consumption, but it's much more difficult to control some of these things. Is it compatible with other chips in the same system? And that's a really interesting question that went on these things here. So do you need to replace everything with a Cherry solution, or can you get the benefits from just one thing there? What are the benefits of in a standalone system versus a complex interconnected system? So one of our observations there was the fact that increasingly vehicles are using GPS. They're connecting to various things in the roadside infrastructure, and will be doing so. Did it give us a way of actually protecting against some of the areas or problems that might come in from areas that we were not in control of? And can it be used in addition to existing diagnostic tools, or are we in a position where it's just a new way of doing sorts of things? It claims it can separate CPU, but does that allow a third party to write code without having access to other areas? And does Cherry provide an effective digital twin or legacy system? And that last one was a really significant question that we asked. And I have to say, we've been quite successful in that. Our method was to go through and look at what may impact the costs as we went through. That assumed an existing approach. So we weren't, let's throw everything away. We are not researchers. We're people that actually have to use this sort of stuff. So that was really important in that way. The way in which cost drivers are likely to trend when changes are made to the design approach, to things like a costing exercise to be taken, where we did a finger in the air looking at what would they go through and what we'd get in relation to that. So I'm not going to read all of these elements out there. This is just a thing going through to actually talk about the methods that we used in relation to these things. And we intended to access metrication. So we essentially went, what are the currently anticipated costs of achieving cyber safety together with the costs of ensuring business outcomes. So our view was, what you're actually seeing is when things go wrong, that manifests itself in your cyber safety case there. And if you combine that with your cost of ensuring the business outcomes, which essentially takes care of the outliers on that, that gave you the areas in which there were savings and things that we could expect to be able to measure. Or to put it another way, if it's not actually making it better, then we need to question why we're doing these sorts of things. And actually measuring how the cost of achieving cyber resilience might be affected were a truly-like solution to be available. As I say, we are conscious there are other ways of doing these sorts of things, but we didn't have enough time and we weren't being paid to look at all of those at the time. Where and how would hardware security need to be integrated into the engineering business activities? So what did that mean? It meant that we started from cost drivers and we looked at the hardware, so the software aspects, the systems costs, the through life management, supply chain management, and the kind of volume multipliers you might expect to see in relation to these. And these are the sorts of elements that we've started to put into our reports. And we are, as I say, very happy to actually get some feedback from you guys if you've got something that you would like to put in there. We've looked at things like what would it take in relation to the tool chains. Some of those we still have questions about. We don't know what it will take on some of the tool chains still to put that in these things into place. Others are elements to do with the fabbing of capabilities to go with these things. But under each of these things here, we've actually looked. We've looked at it in the context of safety critical, but we've also looked at it in terms of products where control systems engineering of some sort is a requirement. We've also looked at entertainment systems in relation to that and have observed that actually it may appear to be something that was worth doing where we have control systems, where we have entertainment systems and things of this nature. It's much less likely that we can find ways why it would be important where we were getting these things in there when we were looking at some of the safety critical elements, because people already have methods of doing these things. And I know that some of the observations that we have seen from some of the OEMs have indicated a 2 to 3 times increase in cost to be able to use this. We think that's at least partially contributed to by the fact that you have to maintain a multi-generational cyber security posture nowadays, and therefore you'd be in a situation where you are having to maintain that across that. So it would likely fall back to something closer to 1, but we have not been able to establish savings. From a software point of view, we wanted to know that it actually fitted inside the types of tools that you'd be using, so the mechanisms that you'd be using in order to demonstrate that you'd got MISRA C compliance and things of that nature around there. The cost of training of skilled people was an interesting thing. So as part of our experimentation that we've done on this, we've been through hoping that we'd be able to use less skilled people. Our conclusions from this had been essentially that we would need to maintain 2 very skilled people in a department in a business in order to be able to make use of this kind of stuff. So the errors that you get out of this during development are not at all easy to interpret. You need to be both a skilled software engineer and skilled at being able to interpret the cherry outcomes. That's potentially a problem for smaller developers, where it's hard to actually justify that overhead. It may not be an issue for larger developers, where that's a reasonable overhead in order to get the benefits that we get out of these things. And I should say these slides will be made available when we finished anyway. So if there are things in here that you find to be of interest, then do feel free to get back there, and we're happy to answer questions in relation to these things. The systems cost was really a really big element that came out of that. So the compliance with the standards and things that came out. Oops, sorry. Was particularly if you're looking at safety and security operating in the context of safety, we were finding some difficulty, not just in being able to being able to use Cherry in those contexts, but part of the observation was it appeared that it would be necessary to be able to get Cherry components that, for instance, had lockstep processors with the type of material you would expect to be getting from somebody that was promising that it would be able to do and was suitable for safety critical. None of the chip vendors that we were talking to had intended to be doing that kind of capability. In the absence of that, our concern was that there was a tendency to produce a single point of failure, and worse than that, that we were able to stimulate that by a cyber attack on these things that was essentially targeting a known memory error, which had the effect of stopping the devices. So there was a fear that we are attempting to substantiate, that we may be taking away some of the key techniques that people are using for things like safety critical, if we bring in components of this type that can be persuaded to fail at will by a cyber attacker. So that was a consideration which we are continuing to work on. If you have opinions on that, again, we would be very interested in those. So we've done at least some things to substantiate that. And then the through life management. So again, part of the assumption here is that if you invest up front in doing the right things in relation to this, that you'd be in a position so that you would reduce the cost of through life management of a cyber compliant solution. And you could reduce the vulnerability tracking, software patches, things of this nature. We have not currently been able to substantiate that would be the case. Certainly that we have not been able to find insurance companies that would be prepared to offer anything around these sorts of elements at the moment. And the ecosystem that's around these devices is not sufficiently developed as yet to allow people to be in a position where they could actually take those advantages. We do believe at some point over the next 5 to 10 years, these will come into place, and techniques such as this probably will be in a position where they would allow you to improve the costs of cyber management. But that isn't something that you could expect to reap as a benefit in the short term around that one. Supply chain management, again, was a really big issue around that. You were at risk of actually having to go and look at much smaller subsets of people that could supply the devices that you were after, that had potential cost consequences associated with it. And it was not clear how liability transfer would work in the case of this. So we did not find anybody that was intending as a chip vendor doing Cherry to actually stand up for and be liable for the consequences if it malfunctioned. And we did not find that people who were acting as a tier one were intending to make any claims that they wouldn't otherwise have made in going forward. So how liability transfers work up and down the chain, it wasn't at all clear, but there were consequences, at least in the short term, from the fact that you'd be fishing in a very reduced pool around these sorts of things. What did we use as our database, as our data points for this? We were fortunate to have access to about 500 plus person years and about 2.5 million lines of code that we could test things on. I will tell you that this was properly engineered code that had gone through MISRA C and C++ and Cert C. We were not seeing memory errors on it generally because these techniques have been used to try and get rid of that sort of stuff in the first place. If I characterize the types of errors that we did see out of here, however, what we saw was 2 errors, which out of 4, which were which it was not clear were actually memory errors at all. However, we did make a conclusion that this was possibly a useful way of allowing you to scale teams, because whilst they weren't technically memory errors, and whilst it took some time to look at them and conclude what they were, it did reflect good practice that had not been passed on from one generation of engineers to the next about the best ways to use some of the tools and the best ways to use some of the implementations. Or to put it another way, MISRA C and C++ and Cert C are not absolutely restrictive in the way they allow to use that, and many organizations have best practices which this was a helpful way of being able to scale some of those teams in relation to that. We found one memory error in a piece of test code somewhere, and the other memory error that we found around this was again in a piece of ancillary code that was not being used as part of the main product. So we didn't find that we were finding memory errors, but that's because the tool chains to allow you to try and address these things are very well developed in this kind of industry. We did develop a set of initial economic hypotheses, and we did work out how to put Cherry and devices using Cherry into our development processes. They had an initial cost in the order of £20,000. However, following that, we were able to operate at more or less zero cost. And they operated in much the same way as a digital twin that we had previously been using many of our static analysis tools and things for. So there were benefits that were associated with that we got out of that, and as I said previously, which we felt we were able to exploit because we had the necessary size of team around that to allow us to maintain the expertise around that one. We looked at things like the supply chain and how those sorts of things fitted together and what dysfunctionalities are. I've compressed down on here 4 sets of hardware errors, and parts of this are designed to say, that in many cases, the bigger cyber problems and the most significant cyber problems that this industry is wrestling with are those to do with things that are embedded into the hardware. So things like the Spectrum meltdowns, the things to do with reliability engineering, and things to do with contradictory objectives and trusted execution environments. With the point being on each of these that the disjoint between the amount of time it takes to get back out a safety critical system and the time that it takes to complete these is actually representing a significant vector of attack. So we are conscious that it took about 10 days to fix Spectra meltdown, but it has taken far longer to work out what may not be running on those components. We looked at some of the volume effects, as I've said, the chip manufacture, the cost of developing the tooling and things. So our basic conclusion in relation to this is there will be a significant cost penalty for anybody assuming that they would like to go in this way, until such time as we could be in a situation where the transition to using these types of techniques was in place. And we would anticipate that would be at least a 5 to 10 year period of time that it takes to go through that one. The security and functional safety advantages in relation to this was interesting. We looked at the legal aspects of how to put these things in, what you could go to court with. Our main point around this is that people don't really generate, and OEMs don't generate significant revenues post sale. So there was a real incentive to be able to reduce the ongoing costs associated with cyber. However, firstly, we noted that it was unlikely, and nobody is really advertising that because you just make yourself a target. But the second thing that went with that was it wasn't really something that we could substantiate that would actually work. And indeed, the more that we were seeing changes from generation to generation and as new things were being brought in, the more we were actually looking at a situation where it might be difficult to justify this, at least based on the evidence that we have today, that this would introduce a significant saving in through life cyber costs. I'd like to give some acknowledgements around this, particularly David Battersby, who's helped me, Kirsty Perrett, who's off, and Gareth Davies from our team in Ebervale, my team at RTSI, and as well as I say, the WMG, AESIN, and the work that we got, support we got from UKR around that. Quite a lot of the information that you've had here was originated out of semi-engineering and details and things that we got from what chips cost in relation to that. And my last slide before I finish, I think, is essentially we had a set of questions we are still looking to get answers to. If you feel you'd like to contribute to where we are, do feel free to chip in on any of these things. There's a contact address at the bottom there, and we'd be very happy to hear from you for at least the next month, and probably after that. And with that, thank you very much. And if you have further questions or any questions you'd like to ask, do feel free to ask.
Okay. Hi, thanks very much, Peter. Fascinating as always. I particularly enjoy listening to your presentations just because they're so well rounded in terms of the high level and the detailed view of the world. And I picked up this point about piece cost, the component cost versus actually what it takes to get that done. So the development and life cycle management. And what would it take for, I'll start the question, what would it take for a company to be compelled to deploy this? Would it be a policy thing or a mandated requirement, or is it just the need to do the right thing?
So I think the first observation that we made is there is nothing you're achieving out of this that can't be achieved in other ways. Mm-hmm. And therefore what you're looking at, that's why we said that what we were looking at was a cost benefit analysis associated with these things. Mm-hmm. It could be mandated. However, I don't think that will be the case. People generally wouldn't mandate for these sorts of things. Mm-hmm. I think, and indeed, I believe that would be bad, shall we say? So I firmly believe that as an engineering activity, for the activity we're in, it is really important that we concentrate on the economics of these things. Mm-hmm. Yeah, it should be that this is the best solution, and that should manifest itself in less cost in something. It should So I often say, you always get benefits and disbenefits. So we took for granted all the benefits about memory saving and memory safety. We took for granted all the benefits that were associated with what that might mean for containerization and not having to go for bare metal components of that sort. But it comes at a cost in terms of reduced choice in your supply chain. It comes at a cost in terms of what you have to train people to do. It comes at a cost in terms of, so there's a whole sequence of those sorts of things. And we think there is further research work to be done that's actually associated with some of the fundamental techniques, for instance, of safety criticality, that it might be undermining some of the way that some of those work. By giving you different ways of doing cyber attacks. So as a safety person, I'm fundamentally dependent on things not failing in parallel. I need them to fail in sequence, and this kind of gives that single point of failure there. So what would it take? It would take starting to answer those questions in a much better way. It would take making sure that it's in the tool chains that you guys use, so that it's not an exception, as it were. And getting to that point, and actually, oddly, it's quite close to the tool chains. It's not that difficult to incorporate it. So I guess that's my shortish answer to what you said, Gunny.
Thanks, Peter. I've got a question here from our dear friend John McNichol. John asks, first of all, he thanks you, Peter. Could you clarify your comment about the much larger costs or longer time compared to the 10 days to fix Spectre meltdown?
So the observation there was at the point of a chip supplier, it was 10 days to fix it, and and say we can stop the preemptive fetches and things of this nature, which roughly, withdrew 25% of the cycles that you had available. But that then left the OEMs who are responsible for the safety answering the question, what's not running in the 25% of the cycles I haven't got? Or do I leave it exposed? So at the systems level, there's a very significant analysis that takes place. And it is one of the problems that I'm seeing at the moment, that the legislation that's coming in causing product suppliers to keep updating their stuff in relation to cyber threats. They can be updated very quickly, but the systems that use them can't be updated at anything like. So if you think about what I have to go through to get regulatory approval to put that back on the road, that isn't a quick fix at all. And that was the observation that we were making there. It's kind of made it easier to produce memory errors, to do these sorts of things in a running system, and therefore you've sort of introduced a disjoint around those sorts of things. So it doesn't run, but it now gives me a consequence.
Excellent. Brilliant. Thanks for that, John, and thanks, Peter, for that. So the chat is open for more questions. We've got 2-3 minutes. So feel free to throw questions towards Peter whilst he's here.
And I can't read the chat net, Yanni, so if there's anything in there, you'll need to let me know.
I will do. I'll read it out. Don't worry. Yeah. Okay. Whilst people are thinking, something came to mind. Of course, we're talking about Cherry in this instance and the economics of. Is Cherry the only solution in town, or is it a specific of a generic set of opportunities or solutions?
So it's absolutely not the only solution in town. It is the one that we were asked to look at in relation to this. And it does have some very interesting characteristics. So particularly it has this lovely characteristic that I, at least in theory, can run my existing code base on it and get benefits from the point of view of memory safety. That's a really major thing that you get out of this. So, but there are, as there have been for many years, there are memory safe languages. There's we've had Ada since whatever it is, the 1960s and things. More recently, programs like Rust have been coming out as achieving the same. And these are obviously useful in the event and would be usable if you're recoding everything. But as our example gave on that one, our data point was 2.5 million lines of code and 500 person years. That's a lot of cost to recode. So you wouldn't want to be doing that kind of stuff. On the other side, many chip vendors have recognized memory safety, as we've known for, as I say, 40 years or so, as a problem, and they've put proprietary solutions of one sort or another in there, and there's a real virtue in some of that diversity that you get out of that. Some of those are linked into compilers and compiler chains on things that you might want to do there. So there is a real range of different ways that you could be approaching some of these things, and they all come with different benefits and disbenefits into your cost of operation. And then alongside that, using C and C++ in a way that is memory safe is at least a significant part of the driver that was behind the MISRA Cs and the Cert C type applications there. How do you use it in the right way? So it's not the only game in town by any means, but I think the other one that went with that was I know if you look at the studies from people like Ericsson, from people like this, you get 40% savings on containerized architecture, which is obviously very fashionable at the moment compared to soft implementations. But that ties you to a particular component. So some of the things that we were discussing there of, okay, you could get that, but you'd be tied to this. Those are considerations that this would give you more flexibility on your supply chain, with most of the benefits that you would get out of a bare metal solution on containerized architectures.
Super, thank you. So we are running out of time. I think there's one or two more questions on the chat. What we'll do is we'll take them offline. I'll put them to Peter and we'll send a response to you all. And I'll show you how we do that. But first of all, I just want to thank Peter for his time. A great presentation. We will see Peter next week at the IOTSF conference, and I'll talk about that in a second. But thank you. It's been a really interesting project. You know, we've been part of this project as a partner as well. And thanks to Carsten and Dan at the team at WMG and Warwick University as well for their excellent work as well on the project. So thanks again. And with that, I'm just going to take 2 or 3 more minutes of your time to talk about some of the things that are coming up on our calendar. So thanks again, Peter.
Thank you so much, Gunny. And thank you for everybody who's listened.
Okay, so I'm just going to share my screen very quickly. I'll take a couple of minutes and no more. Okay, can you see that? That should be up there now, yes? There we go. Okay, right. So yeah, so AESIN, of course, you know, as I talked about AESIN, big question for us, you know, we've been running these tech talks, as I said, for a couple of years, very successful. It's a great platform for us. And we have space for one more talk this year between now and the end of the year. November is a very busy time for us, so we couldn't actually find a date, but really between now and then. And if you would like to talk on the platform, the invitation is open for that last slot. We can make it a festive one as well. And so please, you know, get in touch with me or Chris to express your interest. Emails at the bottom. And we are open for applications for next year's talks already as well. So if you can't manage this year and you'd like to use the platform for next year, then again, please drop us a note. As you've seen, it's 25 to 30 minutes of an interesting talk and then a chat afterwards. So it's fairly light touch, but it's a great way of just getting a platform. And we want to use, again, we encourage, you know, your upcoming generation of leaders and engineers and technologists to use the platform as well. So if you'd like somebody to come and talk about their work from your organizations that would normally not have a platform, we'd be delighted to host them as well. As for events, so just very quickly, following on from the presentation, the RESAuto project is coming to an end. And we have a showcase event, the last one of the project, happening on the 14th of November at the Tyler site in Evervale. I will share this slide set as well, and also put the links on the chat. Please register through the link. You know, we've got about 40 to 50 spaces, so it will be first come, first serve, and that promises to be an excellent event. We'll also have our security and resilience special interest group presenting in the afternoon to talk about future topics. So it'll be a very interesting and well-rounded event. So you're all invited to that. Our systems engineering interest group has an online meeting on the 27th of November, and that's very much talking about systems engineering in the context of connected mobility and cyber physical systems. And we run that jointly with the ITS UK and the Transport Technology Forum. If you're interested in that, send me an email and I'll get you on the invite list. The IOTSF conference, so Peter will be presenting there as well. It's next week. And if you haven't registered, you really need to register. It's one of our flagship events. I will be there for sure. The link will be shared again. There are spaces available. It's in London on the 23rd of October. The next one, the last one before I announce the AESIN conference, the awards dinner. This is an outstanding event. You know, we love it because it's a celebration of the year. It's showcasing and celebrating technology excellence in the UK and our communities. It's a fun night with plenty of food and drink and celebration, a bit of entertainment as well. And that's on the 4th of December. Again, you can register to attend. You can actually buy team tables of 10. So your organization can actually use that as a great way of bringing your team along. And it's a great event, as I said. And also, if you'd like, you can sponsor an award. We have a number of awards. You can sponsor an award, and an award sponsorship also comes with a table included as well. So if you're interested, go to the link or get in touch with me, and we'll make sure that you get a chance to attend. And finally, the AESIN conference, we announced when we closed the conference this year. It's next year on the 19th of June, British Motor Museum. Registration is already open through Eventbrite, as we said at the webpage. But if you'd like to enter to register, you can. If you'd like to sponsor, please get in touch. Or if you're interested in hosting a chair a session, again, you have to get in touch with me and we'll make sure we note that as well. And that's about it, really. And the last one, really, I'll share these slides, is if you're not a member of AESIN, then the question is, why not? You should be a member. As you can see, we're doing some outstanding stuff for the industry, and we'd love to have you on board. Get in touch with me if you're interested, if your organization is not a member yet, and we'll make sure that we can get you on board. And with that, so I'd like to thank you all for attending, and I hope it was a useful and interesting session. And we look forward to seeing you at one of our next events. Thanks very much, and I hope you all have a very good afternoon.